P is the circumcenter of triangle ABC. We will need that later, but for now, we need to find the slope of AB so that we can say what the slope of the line perpendicular to AB is. Okay, so let's talk slope. Okay, so the slope of segment AB. Well, looking at segment AB, it seems to go as far as rise and run, it's up 2 over 1, up 2 over 1. So the slope is 2 over 1, or simply 2. But then we are supposed to find the slope of a line that would be perpendicular to AB. Remember that a perpendicular line will have a slope that is opposite and reciprocal to the first line. So if this is positive, a perpendicular line will have a slope that is negative. And if this is 2 over 1, the reciprocal will be 1 over 2. Okay, so this would be the slope of a perpendicular line. It's negative 1/2. So that's the answer to part A. Find the slope of BC. What is the slope perpendicular to BC? Okay. Well, BC is a horizontal line. So the slope of BC is 0. So this has slope 0. So, you know, a perpendicular line would be a vertical line which has no slope or undefined. Okay, so there's that. Now, what about AC, this one over here? What's the slope of that, and what about the perpendicular? So let me change colors for a second. Let's do blue. So talking now about the slope of AC. So the slope of AC, this seems to be going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So the slope of AC is negative 1 over 1, which of course is the same thing as just negative 1. So the slope of a perpendicular line should be opposite and reciprocal, opposite in sign. So if this one is negative, a perpendicular line will have a positive slope. Now the reciprocal of 1 over 1 is still 1 over 1. Okay, so of course 1 over 1 reduces down to 1. So the original line AC has a slope of negative 1, but a perpendicular line will have a slope of positive 1. Okay, so positive 1. Now find the midpoint of AB. Now we do not need to do the average of the x's and the average of the y's. We can use our common sense. Okay, let's get rid of some of that. So the midpoint of segment AB would be right here. Okay, you see that it's up 2 over 1, up 2 over 1. So this is the spot that's right in the middle. So the midpoint, counting from the origin, is negative 2 comma 1. So let's just mark that down. Find the midpoint of BC. Let's see, 1, 2, 3, 4, 5, 6. So the midpoint is going to be right here in the middle, which is 0 comma negative 1. Find the midpoint of AC. The midpoint of AC is going to be right here. Okay, if I went down 2 over 2, down 2 over 2, I can see that this is going to be the middle. And that is the point 1 comma 1 for the record. 1 comma 1. Now find the coordinates of P. Well, wait a minute, what's P again? P is the circumcenter. So really we were doing all this in order to find the circumcenter. Now we're going to need all those perpendicular slopes we were finding. So remember, when we for each one, we'll have to do, for AB, we'll be using the -1/2, because that should be the slope of a perpendicular. So let's go through this one by one to find the circumcenter. All right, let me get rid of some of this extra stuff that I don't need. All right, what we need are 3 perpendicular bisectors, or at least 2. Okay, because circumcenter is perpendicular bisectors. Okay, it's the intersection of perpendicular bisectors. So let's do the easiest one first. I'm going to start with side BC. In fact, you know what? Let me color coordinate this. Okay, so side BC, I'm going to color it in red. All right, so let's find the perpendicular bisector of this thing. Well, this is the midpoint, and the perpendicular, so that makes this a bisector. So now we just got to go perpendicular, and that'll just be a vertical line. Okay, so this will be the perpendicular bisector. Okay, so this is the perpendicular bisector of side BC. In fact, I think I'll put a little box right here to show that it's perpendicular, and it's the midpoint, so it's a bisector. All right, so far so good. Now let's pick one of the other 2 sides of the triangle and find another perpendicular bisector. So let's go ahead and do let's do side AC. Okay, so we've already got the midpoint there, so I'm about to do side AC, so I'm going to color it in blue. So there's the midpoint. Now we have to make sure that we're perpendicular though, so let's be careful and use the slope. So we're doing AC, so remember a perpendicular line will have slope +1. So starting from this midpoint, that means up 1 over 1, like this, up 1 over 1. Okay, I can follow the same pattern in the other direction and go down 1, left 1, like this. Okay, so these dots are showing me where the perpendicular bisector is. I can already see where it's going to intersect, right there. You know, really at the origin. But let's go ahead and draw that line. So this line that I'm drawing right now is the perpendicular bisector of AC. Okay, so that is the perpendicular bisector. Again, I'm going to put a little box right here because here's where it's perpendicular. It's the midpoint, so it's a bisector. So I can already see right there where the red line meets the blue line. That is, you know, that's the circumcenter. So I could already answer the question. It happens to meet right at the origin, 0, 0. Interesting. So what are the coordinates of the circumcenter P? 0, 0. That's the answer. Now, just for practice, let's go ahead and follow through and find the other perpendicular bisector. Okay, I think I will do this one in green. Okay, so here is the midpoint, of course. Now, AB, we looked at the slope of that earlier, so we decided that a perpendicular line will have slope -1/2, so that's down 1, right 2. So starting from this midpoint, if I go down 1, right 2, I'm going to land right there. Okay, I can follow this to the left as well. So again, I can see it's going to intersect at the origin just like the other 2 did. But let's follow through and just draw it. So here's my final perpendicular bisector. Okay, and it's perpendicular right here. When I say perpendicular bisector, it's perpendicular to this side, and it's the bisector of this side because it's in the midpoint. So it does intersect at 0, 0. So that just confirms that that is the circumcenter that we were looking for. Now, we are supposed to prove some stuff. Now, this red line is kind of in my way. I'm going to delete that. Now, look at question H here. We're supposed to prove that AP equals BP equals CP. Look, the point of this is, remember, what's the special property of the circumcenter? We're talking about the circumcenter here, right? What's the special property of the circumcenter? Do you guys remember that the circumcenter is supposed to be equidistant to the vertices? Guess I gotta delete some of this stuff. The circumcenter is supposed to be equidistant to the vertices. So this is supposed to, point P is supposed to be the circumcenter. But if this is the circumcenter, then it is supposed to be equally distant to the vertices, meaning the distance from P to B, and from P to A, and from P to C. Those distances should all be the same if this is the circumcenter. So they're asking us to prove that. Alright, so these are the coordinates of A, B, and C, and then point P is the circumcenter that we just found, and that circumcenter was 0, 0. Okay, now since we know that the circumcenter should be equally distant from the vertices, it should be equidistant to A, B, and C. If I find those three distances and using the distance formula, it should make the same answer. So let's check it out. Let's just make a table like we always do. So they're saying AP, BP, so here we go. AP means distance between A and P. Okay, B is just the distance between B and P. And CP is, you guessed it, the distance between C and P. So this one is going to be like this, from A to P. So that's going to be, okay, I'm going to do 0 plus 1 squared. Alright, and then 0 minus 3 squared. Okay, that's going to turn out to be the square root of 10. If I do BP, that's going to give me 0 plus 3 squared plus 0 plus 1 squared, and that's going to equal square root of 10 again. One more time. If I do the square root of, now I'm doing from C to P, so this is going to be 0 minus 3 squared plus 0 plus 1 squared. And once again, that is going to be square root of 10. So we have shown that these three distances are all equal because they're all equal to radical 10. Okay, and finally, number 3. This is just your basic straightforward problem where we do the three distances and then decide what it is. Wait, is that right? Find the circumcenter and centroid. Okay, I take it back. Let's start by finding the centroid. Remember, the centroid, that's the one where we just do the average of the x's and the average of the y's. Centroid is the one where we do x plus x. Whoa. The centroid is the one where we do x plus x plus x divided by 3, comma, y plus y plus y divided by 3. Okay, the circumcenter is the one where we have to do perpendicular bisectors. With the slopes and see where they meet. So let's go ahead and do the centroid first because it's so easy. So for the centroid, we're just going to do the average of the x's. So the centroid will be -7 plus -3 plus -3 divided by 2. And then the average of the y. So that's going to be 3 plus 7 plus -5. Oh, I made a mistake just then. I have to divide by 3. We're taking the average, so we have 3 items. We add up and divide by 3. That's how we'll find that average. So when we do that, this is going to make -13 over 3, comma, okay, 3 plus 7 is 10, minus 5, so that'll be 5 over 3. Okay, so these are the coordinates of the centroid. We just did the average of the x's and the average of the y's. Now, let's find the circumcenter. Okay, let's draw this triangle. So -7, comma 3 is going to be right here. -3, comma 7 is going to be right here. And -3, comma -5 is going to be right here. Alright, so here's the triangle that we are dealing with. Okay, so this is the triangle that is being described. So we need to find the circumcenter. So to do the circumcenter, we need we need 2 perpendicular bisectors. 3 would be like extra. So let's start with finding the midpoint. So this vertical side should be pretty easy. Let's see how tall it is. It's 12. Okay, this is 12 high. So that means if I go 6, that should be the middle. So 1, 2, 3, 4, 5, 6. Okay, so this should be the midpoint. So I'm trying to do perpendicular bisector. So bisector means it's in the middle, so midpoint. Now perpendicular, this is vertical. So a horizontal line should be perpendicular. So if I just do a horizontal line, I should be golden. Okay, so here is one of my perpendicular bisectors. Okay, so this blue line is one perpendicular bisector. That was the easy one. We need one more. I will go ahead and do the shorter piece up here. So let's start by finding the midpoint of it. Okay, so here is the midpoint right here. Now, to make sure I'm perpendicular, I have to be very careful about how I do the slope. So let's see, let me have a little space over here. So let's talk about the slope of this line. The original slope, I see how it's going up 1 over 1, up 1 over 1. So the slope is positive 1 over 1. But that's going to be perpendicular to, and I'm thinking opposite and reciprocal. So it's going to be negative something, and then the reciprocal of 1 over 1 is still 1 over 1. That means down 1, right 1 from here. So if I do that, down 1, right 1, kabam! Right there. Did you see where it intersected? Okay, I'm just drawing a few more for completeness. Okay, so these dots show me my other perpendicular bisector. So this is the perpendicular bisector right here. Okay, so those are two perpendicular bisectors, and hopefully you can see right where they intersect. Oh, I didn't really mean to do that. It's blue. Okay, can you see that the two perpendicular bisectors intersect right here? Okay, so the coordinates of my circumcenter are going to be -1, 1. Alright, so that's how you find the circumcenter. Is there anything else we were supposed to find? Find the circumcenter, it's -1, 1, and the centroid, that was -13 over 3, 5 over 3. Alright, I think that was it for the homework tonight. Is that right? Okay, so homework wasn't too bad.